Welcome to the second lecture. Here in this class, I am going to discuss about general and particular solution of a differential equation. As we have discussed in the first lecture about a differential equation, what is a differential equation, what is order and degree of a differential equations and all. And we have also solved exercise 9.1 of CBSE syllabus class 12. And now the continuation of it, general and particular solution of a differential equation. So the main focus is on this one, exercise 9.2 here in this. So first let me explain what is general and particular solution. Generally for an equation, what is a solution you know, right? For example, x plus 4 is equal to 0 is an equation is there. Okay. So what is the solution of this equation? Minus 4 will be the equation of solution of this equation, right? So that means minus 4 plus 4 equal to 0. So 0 equal to 0. So for x is equal to minus 4, the given this equation 1 will satisfy. That means whenever x equal to minus 4, I substitute in the given equation, LHS is equal to RHS it is giving. So I can say here that x equal to minus 4 is the solution of the equation. Here it is an equation. Now what about solution of a differential equation? Okay. So that too, we are discussing here general and particular solution. There is, for this equation, I have one solution here. But for differential equation, what is general solution? What is particular solution? Let us discuss. Okay. So let us consider one of the example over here. Differential equation. Let me write it. The one of the differential equation. D square y by dx square plus y equal to 0. Okay. Now I am considering this differential equation. Okay. So in this case, for what y the given differential equation will satisfy, hence that y is called as the solution curve for the given differential equation. Let me repeat once again. Here x value, it is a number, right? It is a number that satisfying the equation, so it is called as solution of the equation. Whereas y here, which will be a function in x. So let me write it as a function in x as phi of x. Okay. So there is some y equal to phi of x and its derivative. Since here we have second order derivative. So when you find out the second order derivative, that second order derivative plus the given function, if it is equal to 0, then that phi of x is called as solution curve for the given differential equation. What is solution curve for this differential equation? How to find out and all that we will come to know in the coming classes. But right now, just this phi of x, I am considering it as a sine x plus b. Why it is coming and all, I'll explain it in the next classes. But right now I'm considering this y equal to phi of x is a sine of x plus b. This is going to be a solution curve for this one. Why? Why? Because when I find out y dash, y double dash and substitute in this one, if it is satisfying the equation, differential equation, then we say that this is a solution curve for the given difference. So let us find out what is y dash first. A is a constant, b is also constant. So a into sine of x plus b. Differentiation is, sine differentiation is cos of x plus b, and inner function is x plus b. That differentiation is 1 plus 0, which is 1. So this is y dash. Similarly, y double dash. What is y double dash here? The a is a constant. Cos derivative is minus sine of x plus b. Again, inner function derivative is 1. So here only just sine of x plus b. Now I am going to substitute y double dash, this one and y, both of them in the differential equation, whether it is satisfying the differential equation or not. Let us check. So y double dash plus y, which is equal to minus a sine x plus b plus a sine x plus b. Both of them are the same function with the opposite signs, which is equal to 0. Means clearly you can see that LHS is equal to RHS. Hence, I can say that for the given differential equation, y equal to a sine x plus b will be the solution curve. Okay. So right now I'm not explaining you how to find out the solution, but right now I'm only explaining that how it is satisfying, whether the given function satisfies the differential equation or not. Depending on that, I can say that it is a solution of the differential equation. Yes, coming to the next thing, y is equal to a sine x plus b. Okay, if you see, this is so called the general solution. Okay, whatever we have the equation over the solution curve over there, that is nothing but the general solution. For giving suitable values or some particular values, for suppose a equal to 2 and b is equal to some pi by 3. So for this particular values of a and b, you will get another solution, which is y equal to 2 sine of x plus pi by 3. So that particular solution, can you see, particular values of a and b are getting a solution. That solution is called as particular solution. Okay, so it is clearly observed that in a general solution you will be having arbitrary constants here. Okay, whereas in a particular solution the fixed constants will be there. That is only the main difference between them. Okay. So based on this one, exercise 9.2 will be there. So let me go with the exercise 9.2. It is just only the verification. They have given the questions like check whether the solution curves will be satisfying the differential equations or not. That is what we are uh, finding out actually in this one. So in exercise 1 to 10, verify the given functions, explicit or implicit is the solution of the corresponding differential equation. This is what it is given. So y equal to e power x plus 1, whether it is a solution of y double dash minus y dash equal to 0 or not. So one simple thing, it is given, we need to just check whether it is a solution for the given differential equation or not. For that, in the differential equation, y double dash, y dash is there. So for that, I need to find out the derivative twice. So first e power x derivative is e power x, constant derivative is 0. Y double dash is again e power x. Now y double dash minus y dash is what? E power x minus e power x, which is equal to 0. So can you see here we got I considered LHS part and I got it as RHS part. So LHS is equal to RHS we are getting. So I can say clearly say that it is the solution curve. This is a y equal to e power x plus 1 is the solution of the given differential equation y double dash minus y dash equal to 0. Now you can clearly see whether it is a general solution or a particular solution. Here in this one, you can clearly see one particular constant is there, not an arbitrary constant. So it is a particular solution also, I can say. Okay. If it is including some constant A or B something, then it would be considered as a general solution. Let's move to the next question. Y equal to x square plus 2x plus c. Y double dash minus 2x minus 2 equal to 0. Again, I'll be considering LHS part. Y double dash. Before that, let me, since the LHS part containing the second order derivative, I'm sorry, first order derivative it is. First order derivative, for that y dash is equal to 2, derivative of x square is 2x and 2x derivative is 2 and constant derivative is 0. So it is clearly observed in our right down. Can you see this one? This the two terms when you take to the left hand side, you will get the required differential equation. That means whatever we have this solution curve is satisfying the given differential equation. Okay. So therefore y equal to x square plus 2x plus c is a general solution here. Why? Because constant c is arbitrary constant here. Right? So it is a general solution of the given differential equation. Let's move on to the next question. Third one, y equal to cos x plus c. Yes, here the general solution containing the trigonometric functions. So y dash plus sin x equal to 0. So in order to check again whether this curve satisfies the differential equation or not, I need to find out y dash. Cos x differentiation is minus sin x and plus constant derivative is 0. So only this one. When minus sin x, when I bring to the left hand side, y dash plus sin x equal to 0. It's clearly observed these two are one and the same. That means this is a solution. So the given one is the solution solution of the differential equation. So it is also a true statement, I can say. So y equal to cos x plus c is a general solution of y dash plus sin x equal to 0. The next fourth one, y equal to root 1 plus x square. And differential equation is given as y dash is equal to xy by 1 plus x square. Here again, I need to find out y dash directly. So derivative of this one is 1 by 2 into root of 1 plus x square, because it is in the form of root x first of all. Root x derivative is 1 by 2 root x. So, and inner function is 1 plus x square. That derivative is 2x. So, 2 will be cancelled out. X by root 1 plus x square. Right? So, y dash is equal to x by root 1 plus x square. Now, I'll write this one as root 1 plus x square by root 1 plus x square. So, therefore, y dash will be equal to x into root 1 plus x square is nothing but y divided by these two multiplication will give us 1 plus x square. Can you see? Here that is what the same thing we got it. So, therefore, the y equal to root 1 plus x square is a particular solution, because here we have a particular constant. It is a particular solution of the given differential equation. So it is clearly observed that the both LHS and RHS will be equal when we find out the derivative, and LHS part when we consider it is equal to RHS part. Hence it is a solution of the differential equation. And move on to the next question. Y equal to AX. And the differential equation is given as xy dash equal to y. So here also same thing, y dash is involved, only first derivative. So in the given differential equation, how many ever times it is given the derivative, that means the order of the derivative is given, that many times we need to do the differential equation. Only first order derivative is there, so y dash I am finding. So a is an arbitrary constant, x derivative is 1. So y dash is a. Okay. So here this x into y dash, I am considering LHS part now. X into y dash, which is nothing but x into a. What is x into a? That is nothing but y. So therefore xy dash equal to y. Hence y equal to ax is the solution. Is a solution of xy dash equal to y. And next one, question number 6. Y equal to x sin x. And the differential equation is xy dash equal to y plus x into square root of x square minus y square, where x is not equal to 0, x greater than y, or x less than minus y. So here again in the differential equation, first order derivative is involved. So y dash I am finding first of all. Here x into sin x, u into v, both the functions are in x. So product rule one can apply. So first u into v dash, sin x derivative is cos x, plus u dash into v. U dash is 1 into v, which is sin x. So x cos x plus sin x will be the y dash. Now, I am going to consider the LHS part, which we have here xy dash. So, x into y dash. So, x into x cos x plus sin x, which is equal to x square cos x plus x sin x. Of course, here we have x sin x, right? X sin x, which is this one entirely can be replaced by y, plus x square into cos x we have, right? So y plus x into, can I write it as x cos x? Yes. Why we are writing like that? In order to get this form, y I already got it. X is there, x cos x, x is also there again. So just this one to be replaced. As we know, y equal to x sin x. Right? Now, what is x square minus y square? Let me write down. Y square is nothing but first of all x square sine square x. X square minus y square is nothing but x square minus x square sine square x. Now x square, if I take common, 1 minus sine square x, which is cos square x. So x square minus y square, I got it as x square cos x. Whereas x cos x we have, right? So here x cos x we have. So x cos x is nothing but square root of x square minus y square. Therefore, x into this entirely will be replaced by x square minus y square. So this is the reason I can write it by side. So again, same thing. Here we got I considered LHS part and I got it as RHS. So hence we can say that given curve, solution curve is a solution curve satisfies the given differential equation. Okay. Let's move to the next question. Question number 7. Xy equal to log y plus c. So can we say clearly here c is involved. So what type of solution it is? Yes, it is a general solution. Now again, only first order is involved. Here also I am going to do first differentiation. So for the given curve, I am going to do the differentiation on both sides, differentiating with respect to x on both sides. So we have to be careful here. It is not like usual x into y. This is one of the function already is in x. Y is also function in x. So it is into u into v format. So product rule is what? uv derivative is nothing but u dash v plus uv dash, right? So x into y dash plus 1 into y equal to log y differentiation is 1 by y into, see, log x differentiation is 1 by x, but in place of x we have y here, right? So inner function derivative has to be done, which is y dash, and constant derivative is 0. Okay, so xy dash, I'm going to consider the y dash by y to the left hand side, y dash by y equal to minus y. Okay, so when we consider y dash common here, xy minus 1 divided by y equal to minus y, or y dash into 1 minus xy equal to y square. What I did here, here at particular place minus I took common so that this minus will be cancelled out on both the sides. So that's why 1 minus xy I have written here, just positive y square I have written. And therefore y dash is what? Y square by 1 minus xy. So it is clearly mentioned here, the restriction they do not give just like that. There is a meaningful for this one. If xy equal to 1, it is not defined, right? So that is why they have mentioned over here xy is not equal to 1. Anyways, so we considered LHS part and we proved that it is equal to RHS part. Hence the given one is the solution of the given differential equation. So one can find out similar way like the remaining problems also.